Okay, we have the function here f of x equals x plus 2, and our instructions are to find a formula for f composed with the f inverse. So the first thing I want to do is find the inverse function f inverse. So we've set f of x equal to y and solve. So y equals x plus 2, and we get the x equals, subtracting 2 from both sides, x equals y minus 2. That is f inverse y equals y minus 2. So now let's do the composition f composed with f inverse. So this is fun, let's go in magenta here. F composed with f inverse, and f inverse domain, we're calling it y here, so we need to put the domain of the function in front here goes there. So this is going to equal f of f inverse of y. And so this equals, so f says whatever you put in me, put it there. Okay? So that equals f inverse of y plus 2, which equals f inverse of y is y minus 2 plus 2, so this equals y. Okay? So really important here. That is, when you compose two functions that are inverses of each other, you put y in, it spits y out. That is, the inverse, so let's look here. Let's look at an example rather than being so formal here. Let's look at the example. F of 2 equals 4. So that means f inverse of 4 equals 2. So if we look at f composed with f inverse of 4, well, f inverse sends f inverse, here we see it sends 4 to 2, and then f is going to send 2 right back to 4. So this is going to equal 4. That's the most useful thing about the inverse functions, is that when you compose them, you get the identity function. That is, this is the same as I of x equals x. Okay? Let's look at it the other way. So we want to do f inverse composed with f now. So again, for f inverse of y, what did we get? Y minus 2. Alright, y minus 2. Good. And now we want to look at f inverse composed with f of, and f is, put x is there. So this equals, by definition, that's f inverse of f of x. Well, if we look here, f inverse says whatever you put in me, put it there. So that equals f of x minus 2, which equals x plus 2 minus 2, which equals x. Again, I can't say how important this is, that the composition of two inverse functions yields the identity function. That is, you put in x and it puts out an x. That is, this is I of x equals x. And so let's look at the same example we did. Let's look at a different one. Let's say f of 5 equals 7. Looking at here, plug in a 5, we get 7. And that clearly means f inverse of 7 equals 5. And if we look at it over here, we plug in a 7, we get 5. And so if I compose the f inverse composed with f of 7, we see that f will send 7. Oops, I should have done 5 there. f sends 5 to 7, and then the inverse will send 7 back to 5. So if we look at f inverse f of 5, f sends 5 to 7, then the inverse sends 7 back to 5. Okay, so very important. Anytime we compose two inverse functions, whether it be f inverse composed with f, we're going to get the identity function I of x, or f composed with f inverse, we see we'll get the identity function I of x equals x. And that will conclude this video on inverse functions.